Okay, in this lesson, we're covering section 3.5. This is where we're going to graph quadratics using x-intercepts, which we also call zeros. In order to be able to do this, we have to remember our factoring. So remember when we're factoring a trinomial, we're looking for factors of c that add to give us b. So things that multiply to give us 8, 1 and 8, 2 and 4, that add to give us 6. It's going to be 2 and 4. So we would say x plus 2 times x plus 4. On this next one, we want factors of positive 12 that add to give us negative 8. But we know if they multiply and give us a positive, they have to have the same sign. But because they add to give us a negative, they must need to both be negative numbers. So is it going to be negative 1 and negative 12, negative 2 and negative 6, or negative 3 and negative 4? Well, here's our 2 that add to give us negative 8, so it's going to be w minus 2 and w minus 6. If we look at this one, we notice on this one we have a negative 20, so they need to multiply to give us negative 20, but add to give us positive 1. If they multiply to give us a negative, that means at least one of the two numbers has to be negative. Actually, just one needs to be negative. So here are some options. And the one that adds to give us positive 1 is this set right here. So we have x minus 4 times x plus 5. Then if we get on to the next one, we notice that it's a binomial instead of a trinomial. So on those, we look for what they have in common. 2t squared and 8t have a 2t in common. So if we factor that out, we get 2t times t plus 4. On this one, we look at 8x cubed and 20x squared. We see they have a 4x squared in common. So if we take that out, on the inside, we're left with 2x minus 5. And that's the kind of factoring that we're going to focus on in this unit, in this section. Now what I want to do is look at how this factoring relates to the graph. So we're going to use what we already learned about how to graph these equations. So let's start by graphing this one right here. We know we need to find the axis of symmetry, so what's the formula for the axis of symmetry? X equals what?
Negative b over 2a.
Okay. So what's our b for that circle equation?
6x.
6, just the 6, right? And then what's a? What's the coefficient there?
No,
what number's in front of x squared?
2. 1.
2.
1.
Okay, 1 is the coefficient, 2 is the exponent. Now I understand why you said what you were saying. You were talking about squared. So b is 6, so we're going to do negative 6 over 2 times 1, which is 2. So negative 6 divided by 2 is negative 3. So we know now that our axis of symmetry is right here. Oops. Let's move that over a little bit. It's at x equals negative 3. Okay. And then let's go ahead and plug that negative 3 in to this equation. We need to do negative 3 squared. What's negative 3 squared? Negative 3 times negative 3 is 9. Plus 6 times negative 3. Negative 18 plus 8. So what's 9 plus negative 18? That's going to be negative 9 plus 8, negative 1. So our vertex is at negative 3, negative 1, negative 3, negative 1. So go ahead and put that on your graph. So you've plotted the vertex at negative 3, negative 1. And when we look at that a and we see that it's 1, we know that the shape is the same as the parent function, so we're going to go ahead and plot our other points. Over 1 and up 1, over 2 and up 4. Now, we know that the title of this lesson is solving or graphing using the x-intercepts. So let's look at what our x-intercepts are right now. Where does our graph hit the x-axis?
Wait. -2,
-2, 0. And?
-4.
Okay, so identify those 2 points on your graph. Those are important. And when we look at those, those are important because that's where it's hitting on the x-axis. Look back at this equation, the factored form. When we factored it, we got x plus 2 times x plus 4. Remember when we were solving these and we had them equal to 0? And we said what value of x makes the first one 0? What plus 2 gives us 0? -2. And what plus 4 gives us 0? And aren't these at -2 and -4?
That's it?
So could we have used this to graph it?
You've got it. This is so easy.
So this is a really nice, helpful way to graph. It does, but it only gives us the x-intercepts. So there will still be work to do, but that part is going to give us the x-intercepts.
Can we find the
Why?
the axis of symmetry and like where you plot like the vertex from that?
Yes. So let's do that with, let's do this one.
Okay.
Okay. I'm gonna erase all of this. So it's not really. When we look just at this one, if we set that equal to 0, w minus 2 times w minus 6, if we set that equal to 0, what value of w would make the first set of parentheses 0?
2.
2. And what would set the second parentheses equal to 0? So our x-intercepts are going to be at 2 and 6.
So how do we do that?
All right. Where is the axis of symmetry from there?
Middle.
The middle. And can you find the middle?
Yeah.
Yeah. How hard is it for you to find the middle?
Not hard.
Not hard. So let's go ahead and sketch in where that middle is.
Okay.
What's the equation of that line? X equals what?
4.
Good. So all we did was plot those 2 points, and we already know right where the middle is. And if we know that x is 4, remember what we were doing before, we just plug it back in to find the y. So to find y, we're just going to do 4 minus 2 times 4 minus 6.
Oh my goodness. -2. Wait, 2 -2?
2 times -2, which is
-4.
-4. So down 4. Right there.
Oh my gosh, this is so
And we have those 2 points.
easy. This is it?
Yeah, that's it.
Oh my gosh, this is so easy.
Do you see how big a part of it the factoring is, though?
Yes, I did.
Yes, that's a huge part of it. So that's what we're going to practice is factoring, plotting the points, and then finding that vertex from what we've got. Okay? Okay, I'm going to stop this here, and then the next video is going to be more of the examples.